Day 14 examples. So let's talk about 34 first. Identify each substance as an acid or base. We're going to chemical equation showing how it's an acid base in the Arrhenius or an aqueous solution according to the Arrhenius definition. Key identifiers: hydroxide and hydroxide. And if I go to orange here, H out in front, H out in front. So if we have hydroxide, we're base. How is sodium hydroxide a base? NaOH, aqueous, just dissociating to sodium ion and hydroxide. Sulfuric acid, we have for B, H2SO4 going to 2H plus SO4 2 minus. Same thing with HBr, H plus, bromide, and strontium hydroxide. Hopefully this was pretty straightforward for you. Next one, 36. In each reaction, identify the acid, the base, conjugate acid, conjugate base. Bronsted-Lowry. Okay, so for acids, I will do yellow for acids and blue for bases. So I look, how do I identify acids? Well, it hasn't changed. Still H out in front. H out in front, unless it's water, H out in front typically means acid. So HI is probably going to be the acid, which means water is going to be the base. And if I look on the other side, does this H from HI go to water? Yes, there's H3O plus. So that's my conjugate, and then HI is the other one. I minus the other one. So let's write this out. So I will do acid, base, conjugate base, I'm sorry, I said that backwards. Conjugate acid, conjugate base. The next one, key element here, N. Hopefully you see the N. And then you see N, there's an H and a plus sign. That's very, very important. And of course, hydroxide will always be what? Hydroxide will always be a base. In this course, hydroxide is always a base. That means this is a base. That means water is the acid. Acid, conjugate base. Which means ammonia here, this is methylamine. That's a base, and we have the acid. So I'll use green for this one. We have base, acid, conjugate acid, and conjugate base. C. So if you look at carbonate, the first thing I notice is that carbonate has no protons to donate. If we have no H's to donate, we cannot be an H plus donor. And if we're not an H plus donor, we have to be an H plus acceptor because we cannot donate. So if we're H plus acceptor, we are a base, which would mean water is the acid. And hydroxide would be the conjugate base. Again, always a base. And bicarbonate's the conjugate acid. I'll use red for this one. So base, acid, conjugate acid, conjugate base. And finally, D. You notice we got another strong acid, HBr. So that should be recognized right away as a strong acid. Bromide would be the conjugate base, and so water would be the base, and conjugate acid for hydronium. So acid, base, conjugate acid, and conjugate base. And hopefully that works out for 36. .48. So we have to calculate hydronium, and are we acidic or basic? If we remember the concentration of hydronium multiplied by the concentration of hydroxide equals 1.0 times 10 to the negative 14th at 25 degrees Celsius. I have hydroxide, so I can calculate hydronium. So for A, and I'll put them right here, hydronium will be in red right there. So for A, I will have hydronium equal to 1.0 times 10 to the negative 14th divided by hydroxide, which would be, in this case, 1.1 times 10 to the negative 9th. If we do this, what do we get? Put it in the calculator. 1 times 10 to the negative 14th divided by 1.1 times 10 to the negative 9th. I get 9.1 times 10 to the negative 6. Well, negative 6 is much bigger than negative 9, so A is acidic. We're going to do the same thing for B, which is 2.9 times 10 to the negative 2. 1 times 10 to the negative 14 divided by, and I already forgot, 2.9 times 10 to the negative 2. 3.4 times 10 to the negative 13th. Well, that means hydroxide is much, much bigger, so that B is basic. And C, 6.9 times 10 to the negative 12th. 6.9 times 10 to the negative 12. I get 1.4 times 10 to the negative 3. So that will also be acidic. There's how you do 48. 49, now we're at pH and pOH. So for 49, there's two ways to do this. pH is negative log of hydronium. Now, we can do pH plus pOH is 14, which is probably easier. Or, because you have a calculator, hydronium times hydroxide is 1 times 10 to the negative 14th. In your calculator, so what we'd have to do in the calculator, we'd either do, we find the pH, we do 14 minus the pH equals the pOH. That's one way to do it. Or in the calculator, you do negative log of 1.0 times 10 to the negative 14th divided by whatever we get for hydronium. And that gives you the pOH. So either way you want to do it, works mathematically. A lot of my students seem to do it the first way. So for A, if I look at A here, the pH would be equal to negative log of 1.7 times 10 to the negative 8 molar, which we do that. Negative log of 1.7 times 10, 7.77. 7.77 is my pH. pOH would be 14 minus 7.77, 6.23. That's all we do. B is pretty straightforward. So for B, we know the pH is negative log of H plus, which was 1.0 times 10 to the negative 7, which is 7, which means the pOH is also 7. It's neutral water. C, pH is negative log 2.2 times 10 to the negative 6 molar, which negative log 2.2 times 10 to the negative 6. I got 5.65, 5.66. And what you can do real quickly, 14 minus second answer, I get 8.34. for the pOH. What's that, 49? Hopefully that does well for 49. Number 50. Now we're calculating hydronium and hydroxide. Going the other way. So what we had pH equals negative log hydronium. We're now going to do that hydronium equals 10 to the negative pH. How do I throw that in my calculator for 8.55? So hydronium is 10 negative 8.55. Well, let's look what that looks like. We do second log negative 8.55. I get 2.82 times 10 to the negative 9th. Again, there are two methods to get to hydroxide. I could take the pOH. I can find the pOH because 14 minus 8.55 gives me the pOH, and then I can do the same math, 10 to the negative pOH, or I can use 1 times 10 to the negative 14 divided by the number I just got, which might be faster in the calculator. Because if I just do 1 second, comma, negative 14 divides second answer, I get hydroxide, 3.55 times 10 to the negative 6. There you go. That's all this is. 4B. pH. So hydronium is 10 to the negative pH, which is 11.23. Hydronium is second log to negative 11.23, and we get there 5.9 times 10 to the negative 12. 5.989 times 10 to the negative 12. And hydroxide, now this is why I recommend it that way. If I just go second enter, and then I do it again, I get KW divided by my answer, I get 1.70 times 10 to the negative third. C, same thing. Hydronium is 10 to the negative pH of negative 2.87. So that means hydronium will be 2.87. And then hydroxide so 1.35 times 10 to the negative third. And hydroxide is 7.41 times 10 to the negative 12. And there's 50. 58. Determine the pH of each solution. Recognize that for A, HI is strong. In fact, that's strong, that's strong, that's strong, and that's strong. Everything's strong. That's wonderful. So we're strong here. Strong acids, that's nice. So the strong acid, since pH is negative log of H3O plus, and the concentration of hydronium equals the concentration of strong monoprotic acid, which we have. So pH would equal negative log of 0.048. Negative log 0.048. 1.32. And there's A. B, same thing. pH is negative log of 0.0895. 1.05. What's going on with C here? C says we are going to have 0.045 molar in one strong acid and 0.048 molar in a second strong acid. I'm just going to take 0.045 molar and we're going to add it to 0.048 molar. 0.093 molar is what I get for concentration of hydronium. Oh, pH, negative log 0.093. .03. And D. Solution that is 1.09% mass HCl. So for D, I got 1.09% HCl and 1.01 gram per milliliter. And that's the solution. So I have 1.09 grams of HCl per 100 grams of solution. And I have 1.01 grams of solution per 1 milliliter of solution. And we got to figure out the concentration of HCl. I know that I have 1.09 grams of HCl per 100 grams of solution. We know that it's 30, I was trying to use a different color here. Let's use 36 point, 36.46 grams of HCl is 1 mole HCl. So now I'm in moles of HCl, and we know density 1.01 gram of solution is 1 milliliter. And we know that there's 1,000 milliliters in 1 liter. So I take my 1.09, I got to divide it by 100. I divide it by 36.46. I have to times it by 1.01 and times it by 1,000. If we do all that, I get 0.3019. And if we do that, the negative log of that answer, I get 0.52. How do I do that? Because I take the negative log of H plus, which is 0.3019, because HCl equals H3O plus, because it's strong acid. And that's it. 64 is actually not what we've covered yet. And so that will conclude the examples for day 14. Take care.